Hello, everyone. Thanks for joining us on the next edition of Cittabase Tech Talks. And we're going to be talking about data quality and AI. I'm joined by Krishnan, our AI practice head. So, Krishnan, what we got today?
Yeah, sure. Thanks, Anand. So today we're going to talk about our new app that we put together for data quality. So it's called DataQual 360. So basically, what we've seen is, just to go through the problem statement, right? So most of the time, what you've seen is AI and analytics initiatives fail to deliver value just because a lot of data quality issues go undetected, and then there are no actionable recommendations, and then it's an intensely manual process as well. And there's a lot of overhead that goes with it. So what we have tried here is to create an automated AI-driven solution that uses Snowflake's native DMF functions and also a kind of a combination of LLMs, prompt engineering, semantic views, and system-generated insights as well to put together a comprehensive dashboard that kind of takes care of the data profiling, data quality needs of an enterprise. It's as you see here in the key highlights. Uh, Basically, a data quality intelligence tool that uses semantic views, DMFs, and then it populates quality metrics for each of the table at granular levels, and also provides AI-driven recommendations as well. Without further ado, let me move on to the actual dashboard.
So,
Just
Krishnan,
a quick, yeah.
in effect, high quality data is essential for AI, but I think we can use AI itself to automate and enhance data quality by detecting errors, and you can clean or deduplicate and automate some validation as well, I guess.
Exactly. So we are leveraging the power of AI
Okay.
to ensure that the data quality is good for AI, BA, and whatnot. So just to run through this tool, we have the four different tabs here. The one that you see here, the run metrics, basically, it kind of, you can choose to run your DMF rules, which internally will use the Snowflake's data metric functions and calculate, the unique, not null, and all of those metrics as well. And then semantic rules. Basically, the semantic rule option is we have created semantic views and associated a bunch of tables with those views as well. And then we have the system run through the semantic views, and we have some LLM powered procedures that actually take in the semantic rules as input and then run through the prompts, try to decipher the semantic views, and actually build the rules themselves into queries. And then the third tab you see is the system rules. Basically, anything that is not already generated by data profiling from a DMF end or rules from a semantic end, we're also asking the system to go study the data and then come up with its understanding of data distribution and come up with any rules that it might think as good fitting for this for that table or data, right? So those are the first tab you saw is where we actually run those rules. You can choose to run the DMF for the semantic or the system rules. This is the DMF results, like what you see here. Basically, we've done the profiling on this table. Let's say we have an employee table here. It was last processed on 19th December. There are 30 fields. The average null count is 63. And there's also a quick preview of the column level metrics here. It tells you what are the unique count, blank percentage, blank count, max and min, and all that. All of this is again leveraging DMF functions within Snowflake. And then you have a column level aggregation for a selected period. You choose the period and see how has the data been. Like for example, for this period, we've seen that on an average, manager ID has got 245 null counts, right? And then there's some quick visuals. Like for example, in the case of employee ID, there are not any nulls, and it's 100% unique, which is what you expect for an employee ID as well, right? So you can choose any field you want, and then you can choose a date range, and it'll kind of pull through. And again, there's a quick numeric distribution as well. Based on what is the standard deviation, what is the minimum, and all that. It might apply more for a field like a salary, for example, right? So that was the data profiling.
All this built using Streamlit.
Yes, all of this application is all internally residing within Snowflake in the native Streamlit. So that's why it's well governed and secure as well, right?
Perfect.
So we move on to the data quality tab. So again, there are two options here. We've already run the semantic and the system rules in the run metrics. So basically, you can choose the database, you can choose the table, you can choose the rule type, whether you want to run the semantic rules or the system generated rules. And then you see the data, right? You visualize it here. You run it in the first tab, you visualize it here. It tells you what is the distribution among all of these categories. So we have basically categorized all of these rules into these 4 categories: completeness, validity, uniqueness, and consistency. So how do we come about with semantic rules, for example, right? So I can quickly walk through. This is just the YAML file, right? So, which is what we are using as semantic view as well. So basically, we have a description here. It says termination date must be on or after higher date is present, right? So we have asked, so we've asked the LLM to kind of read through this semantic view. We have prompted it and then understand any descriptions or any comments here and come up with rules. So that's how it kind of populates these rules as well. And then it tells you totally it has gotten 39 rules out of these 4 categories and what is the failure percentage and so forth, right? So basically, we can look at it here. Let's say higher date validity, for example, there are 4 failures saying higher date cannot be in the future. So, the system has by itself comprehended the semantic view, came up with these queries, executed them, and it tells you the final fail percentage, right? Again, it's a quick view on what is the distribution of failure for this table. Based on it has only 2 categories at this point from a failure standpoint. So it just tells you what is the distribution for those 4.54 records. 96.6% is completeness related, and then the remaining is validity related, right? So again, a detailed rule level report. So the rules are generated, these are executed. You see all of these queries here, right? So it is all generated by the system based on its understanding of
based
the
on the
view.
understanding. Yeah, exactly.
Yeah, coupled with what we have prompted it to do. So it's a combination of prompt engineering, semantic views, and LLMs natively residing in Snowflake. And quick plots, like we might have multiple runs over a period of time. How is the quality fared over time? Like, okay, we see what is the execution time? What is the fail count? We see a kind of a spike in failure on 18th December. The team probably noticed it by running this, and then they've kind of stabilized it going forward, right? So that is kind of view it gives. And in addition to that, based on the latest run, it also gives you a set of recommendations, right? Okay, what are the top issues that it considers? And there is already a rule in the semantic view, for example, that the commission rate should be between 0 and 0.5. It has seen that there are incorrect commission rates, so it has also recommended kind of what to do on that. And it gives you a bunch of AI-powered
so this recommendation are for every run, is that correct? Or
yes, once you do it'll remind that for your most current execution, because that will be the latest and greatest recommendation that you would want. So that was the quick view of the dashboard itself. And you can also feel free to query the table. You can kind of go to the respective tables. You can run a query on those. And this is where the historically we store all the data quality in the HIS table. And the current table is where the most recent results are there. This is for the system and semantic views. And for DMF, there's a separate table as well. So if you query the current table, for example, it will tell you the complete report. How many total columns? How many rows were there? What is the fail count? What is the actual query? And then, for example, in this case, order date should not be null. So it kind of gives you the query, gives you the rule ID, the table name, the field name, the rule name. What is the rule description? It's a comprehensive report. So
comprehensive, quite comprehensive. Yeah. So, Krishnan, sorry, a quick question. Like, what it takes to for a client to implement this application? Like, I mean, as long as if they have their semantic views well defined, this application will take care of the rules definition and all, right?
Yes, exactly. So the key is to define the semantic views in a kind of a organized fashion with your appropriate comments and all that, because the system will inherently interpret your custom rules you have defined in the semantic views or any descriptions, comments, etc., and translate them to queries in the rule validation table. It will take the rule validation table, actually execute those queries, and populate into the DQ reports table as well. So as you rightly said, the semantic view is where it needs to be kind of kept up to date with all the rules. So what it saves here is really it saves time. There's no manual work involved for QA testers to go there and check every field or anything like that. And this is what you see, right? It transforms data quality from a reactive rule-heavy exercise into a more intelligent exercise, right? By combining Snowflake's native capabilities with semantic awareness, metric-driven evaluation. That's why we call it a DataQual 360, because we cover the the whole breadth of what is needed from a data quality standpoint.
Absolutely. Yeah, absolutely. Quite interesting. Thanks, Krishna. Thanks for the demo. And it's quite an interesting one. Thank you. Thank you so much.
Yeah, thanks. Thanks a lot. And thanks for having me.